Hello, everyone, and thank you for joining us today. My name is Peter Ryan. I'm part of the Johnson Controls marketing team, and I'll be moderating the session for you today. In the webcast this afternoon, we're focused on maximizing chiller reliability and achieving your energy goals. And we'll be speaking about the technology and service capabilities that can help you get the most out of your chillers and reduce your energy bills. If you go to the next slide, please. A few housekeeping items before we get started. In terms of the webcast, a couple key things that you need to know on the interface that you're looking at. The mute and unmute button does exactly what it says, and will let you speak. What we're going to do is we're going to use the questions box, which is down on the bottom of your screen. And at any time during the session, you can go ahead and type in any question that you want in there, something you're thinking of, want to ask, clarification, whatever. And that will come to us, and what we'll do is queue all those questions up, and we'll answer them at the end of the session. Our plan is to do about a 45-minute presentation and leave a good 15 minutes at the end for questions and answers. And at that time, we'll be able to unmute you so you can ask your questions verbally as well if you'd rather do that or have a discussion via the chat feature. To let us know that you want to ask a question at the end of the session, use the raised hand button. We'll get a little icon, it'll flag your name, we'll know you have a question, and that'll allow us to unmute you and you can speak to us. One final note here is that this webcast is being recorded. It's going to be posted on our website after the session for replay. So if you have any issues with being recorded, I would recommend that you drop, and then you can go ahead and listen to the replay later. So in terms of topics today, this is a brief agenda here. We'll be talking about connected technologies and how it applies to chillers and how we can get the most out of the chillers. I'm really excited to be joined by two of my colleagues here, Cesar Garcia and Arun Veda. They're experts in connected services and chiller operations and have many years of experience that they're going to share with you today. So with that, I'd like to welcome Cesar and turn it over to him.
Thank you, Peter. So good day, everyone. Thank you for joining us. And to start, we want to talk about a little bit of the history of JCI. So since 1883, JCI has been a leader in building technologies. From the thermostat to today with our OpenBlue technologies, we really transform the environments where people live, work, learn, and play. Our mission is to reimagine the performance of buildings to serve people, places, and the planet. And our OpenBlue platform really is a complete suite of connected solutions that takes in nearly 140 years of our building expertise. It really also serves as our transformation from a building product and solution provider to a digitally enabled business, especially when it comes to service. So whether it is fire, security, controls, HVAC equipment, and now our digital solutions, our OpenBlue platform and connected solutions help solve new problems. We provide better safety and ensure impactful sustainability. So we have some key challenges here, but before we discuss the key challenges, I'm curious, I want to launch a poll question. I want to know, when it comes to managing your chillers, what is your #1 priority? So I'm going to go ahead and launch our poll. The poll is open. Please let us know what your #1 priority is. And it looks like uptime and reliability is the #1 priority. And energy and total cost of ownership tied at 17%. And so thank you for sharing that insight. So the key challenges, so you'll mention that uptime and reliability is a key concern, and what we see here, it is also a key challenges that we see from what our customers tell us. Really, that unpredictability in maintenance costs as well, and this is especially true today with inflation. and really trying to control those costs. Another key challenge that we see our customers experience or they're concerned about is really the lack of in-house experts and the loss of skilled operators. So within our industry, we see this labor set really being crucial, as most of our technicians are nearing the age of retirement or thinking about that in the coming years, and there really is a lack of skill set in the marketplace to backfill those positions. So a key concern is, how are we going to make up for that knowledge gap? In the last couple of years, we had some, we went through the pandemic, and so how can we match the chiller operation to building loads? This was another key challenge that a lot of our customers discussed. And then a very common one, and I'm sure a lot of you all experience this as well, is, how do we make those informed decisions on, should we repair a piece of equipment or should we replace that equipment? And so these are key challenges that we see our customers experience when it comes to operating their chillers. OpenBlue Connected Chillers is a recognized solution, and Arun, I'm going to invite you to go ahead and speak about the Frost & Sullivan Award.
Good day, all. So thanks again for having me on this call. So thanks again, Cesar. So we are very fortunate to have won the award from Frost & Sullivan. They interviewed us with several other providers in this space, and they recognized us as the leader in this space for really driving value-driven, digitally enabled solutions to chiller operations and chiller maintenance in the marketplace. So we spent a lot of effort in building this solution, really focused around customer pain points and understanding what's important to key customers, and also understanding what are the major market drivers that are day-to-day operations and challenges and maintenance challenges in the marketplace today. And really, we are very much laser focused on making sure we understand the pain points that are always changing in the market and building solutions that are able to address this. So this award basically was a recognition of that award. So with that, Cesar, go ahead, please.
Thank you, Arun. So what we see here on the screen is really how JCI views maintenance strategies. And we see we have several different steps here, and we know our customers implement various strategies, whether it's reactive all the way up to very common planned preventative. But the question is, how can we move up that value chain, get to that predictive and proactive strategy? Now, reactive strategies may work well for certain piece of equipment. Think about a room temp sensor. If that goes down, we could go in, replace it, and move on, right? But that's probably not the best way to manage a critical piece of equipment. And that's really where the planned and preventative services come into play, where we could plan a major service during a shutdown, a planned shutdown, right? Or we have preventative maintenance practices based on manufacturer recommended strategies. So tubes need to get cleaned, let's just say twice a year, every quarter, etc., right? Depending on your operation. But really, how can we move up that value chain? And that's really where data comes into play. When we have that data, we could start applying machine learning, artificial intelligence. We have fault detection diagnostics, and that's really going to help enable us to become predictive and proactive. Okay, and so that's really what we're trying to achieve and what we're looking to achieve with connected chillers. And when we implement and we have that data and we move up that value chain, we could start to expect improved life cycle and productivity, lower cost of ownership. Okay, we could increase that uptime and reliability, which you all said was a #1 priority when operating your chillers. Okay, and so before I get into what connected chillers is and how it works, I'm going to launch another poll. I'd like to know how you would describe your current HVAC maintenance practices or chiller maintenance practices. Good. So we have a pretty good distribution across the different strategies here in place. I do see that 24% as reactive, right? But you know, it looks like the 28% planned is the slight leader here. So good insight. Thank you for sharing that. So let's take a look at what connected chillers is and how it works. So connected chillers really is a complete cycle, a continuous feedback loop. Okay, so we have our chiller in place, and connected chillers works with JCI chillers, York, but it also works with third-party chillers as well that are backnet. And so what we do is we connect a pre-configured gateway to the chiller, and that essentially takes the data from the chiller and we send it up to the cloud. Now, the way we send it to the cloud is one of two ways. We can use a customer's network, but we prefer to use a mobile connection, which provides an extra layer of security since it is a dynamic IP address when it gets sent up to the cloud. Once it is in the cloud, we're able to analyze and visualize what exactly is happening with our chillers. Now, our technicians, our chiller experts are there to analyze and help make those recommendations for the client. And based on the service agreement you have, we'll determine how often we're looking at your chillers and making those recommendations for operational and energy efficiencies. Any critical alerts, we immediately notify the technician and we notify the customer saying, we are predicting an imminent shutdown as an example. We need to take action. Now, you're not going to lose, your relationship with the chiller. We still show up on site. Your technician will still show up on site. We're still maintaining it, and we're optimizing it now, right? So all the data that we have and that our chillers have, you have as well through our customer-facing dashboard. So everything that we see, you see as well. And this is a continuous loop. We perform a lot of voice of customer here at JCI, and one of the big items that we always hear is, JCI, how can you champion me? How can you help me get initiative pushed through our vetting process? How can you help me get the capital that I need to make these improvements? And so we're able to do that by delivering tangible results. We have regular reporting that will give you your overall health of your chiller, a comprehensive health report. We perform those regular health checks as well. And then our technicians are constantly providing feedback on the overall operation of your chillers. And the great thing is, we don't have to disturb or interrupt your business to do this. We're able to do this through virtual inspections as well. And so, as you see here, we have a lot of ways in which we can champion you and really provide you the data you need to make meaningful strategic decisions. Now, one of the key differentiators for JCI is our Chiller Performance Index. And what this is it's a number, a value that we assign 0 to 100 that is really easy to understand and help you prioritize where you need to pay, where your chillers need attention and how to prioritize them. So 0 to 50 is critical. We really need to look at that chiller and take action on it. 51 to 75 is an alert. There's some improvements that need to happen, but it's not critical. And then we have the satisfactory as your chillers are operating in a satisfactory manner. There's 3 items that we take into consideration when deriving the CPI number. The first one really is what we call the health check. And this is a proactive way to look at your chillers through our fault detection and diagnostics, okay? So fault detection diagnostics, FDD, is my equipment operating the way I expect it to under a set of circumstances, okay? So your chiller may be operating and meeting set point, but is it operating the way we would expect it to, right? So that proactive approach. The next thing that we're looking at are the safety and warning events. Now, this is really important because I'm always asked, what is the difference between connected chillers and my BMS system? And this is a big differentiator right here. So a BMS system is going to give you about 20 points more or less from the chiller, right? And that's great for control, command and control. But really, with connected chillers, we're able to get deeper into the data. When we connect to the chiller, we're pulling out over 200 points from that chiller, okay? And so, some of those points include that chiller diagnostic codes from the manufacturer. So it's like literally standing in front of your chiller and seeing, having view into your chiller 24/7. And then the third thing that we take into consideration are those cycling events. So for some reason, your chiller shut down, it was able to recover, and it came back online. So we take these 3 items into an algorithm and come up with our CPI score, again, to provide insight and help you prioritize and understand your chiller performance. The way I like to think about it is your chiller is talking to you. It's talking to you 24 hours a day, 7 days a week, okay? Most of us don't realize it or don't really pay attention, right? Until our chiller throws a temper tantrum and decides to break down or cause trouble, right? And then we have that's really when we start paying attention to the chiller and what it's telling us. So connected chiller really is a way to listen to the chiller on a regular basis. Now, our customer-facing dashboard. Another voice of customer, what we hear our customers telling us is we want actionable insights. We want to know how to prioritize the data that our facilities are generating, and in this case, our chillers. And so this really was the goal and is the goal of our customer dashboard, where we have the recommendations up front and center based on criticality or priority, okay? We also have our chiller performance index, which again will provide insight into all the chillers within your portfolio, and you're easily able to see through the CPI how they're performing, which ones need attention, which ones are operating in satisfactory order. And connected chillers is part of a service agreement. However, the platform itself also is a software as a service, and it's continuously being enhanced. And on the roadmap, we have a couple of items that will be released here shortly, which is our chiller stability index. So really, it's real-time tracking on minimizing safety shutdowns and maximizing chilled water temperature stability. And energy is going to be a huge component of connected chillers. And so we're starting to bring in really our chiller efficiency. And, we're going to have our flow meters as part of an energy monitoring service as well. And I'm going to invite Arun to speak a little bit more about our customer-facing dashboard.
Thank you, Cesar. So can you hear me okay?
We can hear you.
Perfect. So yeah, so as part of the dashboard, right, the focus is to understand very quickly what's happening to the entire fleet of chillers. Some of you may have one chiller, some of you may have a group of chillers or even multiple facilities. So understanding what's happening at any time over the entire fleet is extremely important. So the CPI score is made very, very prominent here. So you can very quickly glance and see where the individual chillers in different facilities are, and that makes it very easy to drill down to ones that are really needing attention. On the top of the dashboard, we do have the recommendations. That's the actionable intelligence that is coming from the data that is collecting and the fault detection and diagnostics that's happening in the background. And as we advance this, we will be putting up more of these KPIs that are very, very critical right in the main screen. Today we have them in different parts of the software, but it becomes very prominent because I think energy and sustainability are becoming very, very important to our customers. We hear that on a daily basis now. And so those are going to become very prominent as we go forward with the application. So the idea is we are managing the chiller, or we are observing the chiller in real time, what's going on from a management and a maintenance reliability standpoint, and also the energy performance standpoint as part of the way to understand and better improve the chiller operations as we move along this journey. So Cesar, you want to take it away, please?
Good. Thank you, Arun. So through connected chillers, over the last 6 or 7 years, we've been able to gather over 6 million data points from all the data and all the chillers connected to the platform. And what we've seen is that connected chillers works, and approximately 35% of the chillers connected have had valid early warning signs. And this means we've been able to prevent shutdowns. We've been able to increase efficiencies, whether it be maintenance, operational, or energy. And if we look to the right here where we see critical alerts, maintenance, energy performance, this is just another way to visualize how connected chillers really works. Again, we have the data from the chiller going up to the cloud, and we have a team monitoring those critical alerts. Any critical alert that we need to take action on, we immediately do. We notify the JCI field service tech, who will then work with you, the customer, to address these critical alerts to prevent a shutdown. And then based on your service agreement, we're monitoring for maintenance and energy performance efficiencies, okay? And this is just a cycle that continues to happen, a continuous feedback loop. And so what I want to do is actually launch another poll question. And the poll question is, how often are you currently servicing your chillers? So let me go ahead and launch this. All right, so it looks like half of everyone on this call services them quarterly. I do see that 15% when they break down, only when they break down. And we do have some that maintain them on a monthly basis. So pretty good distribution, but definitely that quarterly is the popular and probably standard option. So Arun, I'm gonna pass it over to you now. Let me go ahead and close out the poll.
Thank you, Cesar.
And why don't you tell us about a real life example case study, Arun?
Sure. So this is an interesting case study because this is a customer. We have a lot of chillers with them, and we monitor a number of chillers on their behalf. It's a mission critical site, so chillers are very, very important for the customer for maintaining their day-to-day operations. So these are just a sample of what happens on a day-to-day monitoring exercise. Here's an example where our chiller expert team was able to detect a chiller surge that was happening, and the data you can see on the little computer screen very clearly. There's a surge happening, and that surge was real. When they caught it, they quickly activated the branch to go check it out, and they actually caught the issue before it became a problem. and they actually corrected the problem, and that prevented a VFD from failing on the chiller. The VFD failure on this chiller is a very expensive repair that could have costed almost $75,000, and it takes about 8 weeks to correct that problem. So 8 weeks of downtime was avoided, and $75,000 worth of work was avoided because we caught it and remediated it before it became a problem, right? On the second side, here's the warning code that the chiller was sending, and that warning code flashes on the screen, and that was again a very important alert that our team caught on time. So this was a power failure that was facility driven. Sometimes chillers are impacted by facility related issues, power, water from cooling towers, all of that are outside the chiller, but does impact the day-to-day health of the chiller, sometimes even energy performance of the chiller. So again, the team was able to identify this quickly, and they went and corrected the problem. Again, of significant savings. This time it was the compressor that would have gotten impacted had this impact not caught on time. So it would have quickly depreciated the compressor's life, so they were able to catch it early enough. And not only they were able to avoid the cost, they were also able to make a positive impact on the energy performance of the chiller, almost to the tune of $2,000 a year, right? So the third one was another example where you can see the data. The data is a little small, but the thing is there. You can see those green bars go up and down very, very dramatically. That is not the way a good chiller should operate. It should be a nice smooth line. So again, the data pattern again indicated there was a problem. Again, a similar type of a problem. There was a chiller surge happening, and the VFD was not responding appropriately. The team caught it again early enough. Again, a pretty significant investment, but was avoided because it was corrected before it became a bigger problem. So again, this is where the connected chiller can be very powerful. If we really harness the intelligence that is coming from data, we can start detecting these issues early on. Machines are really good providing patterns, and those patterns are highly recognizable. And the technology like this helps us to bring it in time in front of the right people. And that really helps to really action out early in the process so that it doesn't become a bigger problem or a downtime that we have to deal with when we are running mission critical facilities. Let's go to the next slide, please. So high level, what is involved in our connected chiller is a number of factors we leverage to make this possible. I'm going to start from the top, like 1 o'clock time frame. The maintenance is very, very important. Chillers are devices that have rotating piece of machinery. They have lots of refrigerant that goes through high pressures. And so they are physical, mechanical devices that need proper care and maintenance and operation. So digitally enabled chillers do provide a lot of insight that helps us to understand those real-time parameters. And if anything starts to deviate from optimal, the earlier we catch, the better we are bringing it back to the appropriate health. And so that is very, very key for us to make sure we capture every possible signature that's of value to us. The second part is if you go around the 3 o'clock time point, right, we have a lot of key performance indicators. We showed a few of them, like a chiller performance index or stability index. We have a number of them built into the platform where we are constantly updating them. And each one of those focuses on different aspect of chiller, from asset health maintenance to stability to real-time operation to energy. Those key KPIs helps us to quickly triage number of assets very quickly. And even if you have more than one chiller or group of chillers or different facilities, you can really monitor them very, very proficiently and quickly with this kind of KPI-based tracking. Then we also have technical support and chiller advisors available who actually do look at these chillers on a regular basis, depending on the type of contract, or if it's some sort of critical alert, it grabs the attention of key people, and we are able to then activate the branches to go check out. Sometimes we're able to do virtual inspections. So depending on the severity of the problem, we have different ways to triage the problem. Anytime we install a new chiller, we highly recommend putting connected chillers. We do that for a number of chillers today globally. And we use this as a way to make sure the chiller was installed properly in the first place. So that is our startup commissioning. We do that through a year one inspection. We make sure whoever installed, the contractor who installed it, all the connections are right, all the setup is right, and it's operating as expected for design. So that's very important to get the chiller up and running the very first time. Then it's easier to maintain over time. So that is a common problem we see in the industry. Sometimes we have warranty programs, premium contract programs. where that relationship extends beyond the year one, where we are able to provide a full glove peace of mind service to our customers for a long-term period. So all that is possible because we are digitally able to understand what's going on at any time in our chiller, and that knowledge base is hugely valuable for us to understand and prioritize our actions. But the other big advantage of having this platform is this becomes a single pane of glass to monitor all chiller assets. We have customers who have chillers in one region. We have customers who have chillers across the globe. And with a single pane of glass, they are able to understand what's going on anywhere in their chiller fleet in real time. So that's got a huge amount of value. And as they also see all the recommended actions show up on the platform, they can also plan the execution of it very, very smartly from an investment and timing standpoint. So they don't have to take down a chiller, and they're able to keep the facilities up and running at all times in the most optimum fashion. Again, energy is becoming more and more important. Chillers are one of the most key energy using devices in a building. So getting very high precision data is very, very valuable. So even if you see deviation starting to move from where optimum is, we can catch it early. We call energy the heartbeat of any equipment. If there's something that is not optimum, it generally starts to show up in energy very quickly. So we are able to quickly catch it and bring it back to action so that we are getting the most out of the chiller from a both performance and productivity standpoint. We have a lot of analytics built in. We are leveraging artificial intelligence and machine learning that's sitting on top of data. We also have services where we have edge AI capability. Sometimes data moves very fast, and bringing it all to the cloud and analytics takes time. So we have the ability to also analyze data right at the edge. And for example, vibration is a good example where the edge AI is a very powerful way to catch it. And so we use different analytics techniques to catch data at the most appropriate time so that we get the most value out of it, so that we are able to action accordingly. And the last thing that is very, very growing industry acceptance is automated control. We have ways to do model predictive control. I'm going to get to the next set of slides. Again, a very unique feature JCI offers. We understand control systems. We understand HVAC systems well. We marry the two expertise together, and we are able to bring to market model predictive control, where we are not just advising on the health and the performance of a chiller. We can even take over real-time monitoring, real-time control of the chiller or the entire chiller plant to create value. And sometimes models are way more faster than a human can do. And if you have a highly appropriate situation where real-time control is very important, either precise control or if you're buying energy in real-time markets, real-time control is highly valuable. And that's where the machine's power comes in. And so we can enable all those outcomes for customers. Let's go to the next one, and maybe Cesar, if you can drop the poll, that would be good.
Yeah, so let's drop a poll right here. And the poll question, let me go ahead and launch this, is we'd like to understand, how do you currently think your chillers are operating? So please provide your feedback here. Perfect. All right. So pretty evenly distributed here between okay and good. So a little bit of investigation needed on those good. Some low-hanging fruit could be addressed on the okay, and 20% of you optimally. Great job. All right. So let's Arun, I'm gonna go back to the slides, and maybe you could speak a little bit about
let's go to the next slide, please.
Operating in energy.
Sure. So the reason we prompted that poll is to get an understanding how different folks are managing their chiller assets today. Energy is starting to become very, very important for a lot of customers. There's a lot of regulatory requirements that are coming on this front. There's a lot of corporate requirements are coming. Everybody is trying to address the climate change problem, which is becoming bigger by the day. And chiller is probably one of the best places to start on that journey. If you have a large building, you have a chiller. In most cases, your chiller is the largest single energy using piece of equipment. And if you take the life cycle cost of operating a chiller, the energy cost is the largest cost in operating a chiller, depending on how it's operated, depending on what energy rates you're paying, somewhere between 50% to 80% of the cost, the total operation of the chiller over its lifetime is spent on energy. So energy is becoming very, very valuable to manage, both from a cost perspective, return on investment perspective, and also achieve sustainability climate goals. And we are laser focused on driving this outcome for customers. One of the things yacht chillers are very good at is they operate in a wide operating range, and they are optimized to operate in extremely high ranges, still providing very high energy performance. And we want to make sure the way the machine is built is able to deliver, and that's where we leverage the data, is to maximize the power of that machine and make sure it's operated at the best possible way so that you get the most productivity out of that machine for the life of the machine. So, and the last few years has also taught us a lot of new things. With COVID coming in, buildings went into a very different occupancy patterns, very low occupancy. Now everybody's coming back to office. The occupancy is changing on a daily basis, which was not possible before the COVID era. Everything was almost operating in a full capacity mode. And so operating chillers, operating building systems, HVAC systems, control systems, they're all getting up to the new challenge of how do we get the max as the operation of these things change on a daily basis. Every Friday is not the same. And so we are now getting into an era where managing building assets and facilities with real-time input coming from occupancy and other variables are becoming more and more valuable to squeeze the most output out of our facilities. Let's go to the next one, please. So in addition to managing chillers manually, we also have the ability to manage it with a machine in the middle. This is where the high performance software comes into play. We have a product called Central Utility Plant, and it not only talks chillers, it talks all the major devices in a central plant. You can have generation resources, you could have boilers. Anytime we have cooling, we also have simultaneous heating and cooling. That is part of HVAC system design, and optimizing it in real time is very critical to get the most out of your facilities and reduce the operating costs. So sometimes, depending on the complexity of facility, the human in the middle may not be sufficient to get the most out of your system. And that's where software comes into play, where these things can operate in very, very rapid speed, and they're continuously changing. They don't get tired, they're 24/7. And we are able to leverage these technologies progressively into more and more sophisticated facilities. And we are starting to see a fairly good adoption coming for these technologies, especially as customers are starting to focus on climate resilient buildings and getting the most energy performance out of the buildings. A lot of our customers are starting to formally report energy performance in buildings. And so the power of technology really comes to help the human in the middle, and really simplifies the operator's day-to-day job of managing their facilities more elegantly. So we're really committed to advancing this technology as we go forward. And the idea is to make it very, very simple for building operators to manage pretty complex facilities over time. Next one, please. So high level, where JCI is going is we want to marry three different things. We build equipment today, chillers, control systems, and lots of other HVAC systems. We have a fairly good leadership position with technology. We also provide field services. The idea is to bring expertise from all these three things together and enhance each of those domains and deliver better products and solutions to our customers. We totally understand that the market is very much laser focused on key drivers. Anybody who has a chiller or control system, we understand it's a mission critical asset in the building. It's an expensive asset. It's got a lot of moving parts. Downtime isn't something that really creates a lot of problem. Our goal is to make sure everything is optimized and running at full capacity, or ability to provide full capacity at all times. Efficiency is key to success of our customers, and we want to make sure that we are driving the most out of these devices as we optimally address their needs using digital technologies. And the idea is to also progressively digitally enable facilities. So you're going to get the most out of low cost, no cost opportunities. Capital investment is expensive and everybody has capital constraints. We completely understand that. And there's a lot of missed opportunity today that can be uncovered with data. And that's where we are laser focusing on. The cost of this technology to the benefit of far exceeds. So we really put a lot of effort to make sure we are enabling digital facilities so that we're getting the low hanging fruit that will otherwise be very difficult to squeeze out. Next one, please. So again, that's where we see the future of building services, digital enablement. And digital enablement really unlocks a lot of opportunities that's stuck today without data. And when we marry it up with service, you have a person who can rely on, who's also digitally enabled. So we are trying to put the people, process, and technology to work to the benefit of our customer. And the more we do this together as a unison, the better outcomes we are able to drive between both the assets and the facilities we are able to manage on behalf of our customers. Let's go to the next one, please. So high level, again, JCI is an industry leader, not just in chillers. We also do control systems. We do building maintenance systems. We provide energy consulting services, energy capital programs. So we are a full service company, and we leverage the expertise that we build within our company to bring to every project. And the idea is to reduce risk. The idea is to make buildings more efficient and more sustainable as we go along. And we also believe digital is a very, very powerful way to quickly achieve these outcomes at the lowest possible cost. So we are really investing heavily on these services and technologies so that we are able to bring these outcomes at the fastest and the most cost-effective way for our customers. And doing so, we think we can really make those facilities some of the best in the industry, and that's where we are striving to. Any questions or comments? Let's go to another slide. Thank you.
All right, thank you very much, Cesar and Arun. Great presentation, a lot of really good information. Now we'll open up the question and answer section of the presentation. And just a reminder, you can use the raised hand button to go ahead and let us know that you have a verbal question you want to ask. And the Q&A pane, you can type your questions in. So while we're waiting to see if anyone's going to raise their hand or has something that they want to ask, we had a couple questions come in during the presentation that we can start with. I think one of them here for, I think Cesar, can you add this solution, the OpenBlue solution you talked about, to older chillers or third-party chillers, or do we have to buy something new?
No, our OpenBlue connected chillers, is compatible with your chillers as well as third-party chillers that are BACnet IP. So as long as they meet those requirements, we are able to connect to the chiller, and it could be added.
Okay, great. Another one came up, and Arun, maybe this one's for you. With the connected infrastructure that you're talking about, can you talk about some of the cybersecurity aspects of the solution and how you protect against external threats?
Sure. So cybersecurity is very, very important. At JCI, we don't think we could offer anything digital unless we follow the best practices in cyber. So in the chiller or most of our connected solutions, we follow the zero trust technology, which is the best practice in the operational network technology. If you follow any major standards, NIST puts out standards. NIST has been putting out the zero trust technology as the way to do cybersecurity of any internet connected device, IoT, as we play. JCI has a leadership position in the market. We'll be rolling this out for all our connected devices, including chillers. So zero trust is the next generation of VPN. A lot of operational networks in buildings have not caught up with the latest that we have with our conventional computers and all the ways we today interact with machines in the world. All IT systems are able to address these zero trust technology. We're bringing the same technology down to every connected IoT device.
Excellent. Okay, thank you, Arun. We had a couple more here. And again, just a reminder, everybody raise your hand. No problem here in taking questions verbally or having a discussion about a topic you're interested in. One of the other questions that came in, we talked about gathering data from chillers and using that data to detect faults and make adjustments. How does that actually work? Like, what do you do with the data to enable that?
Yeah, so chillers are already pre-programmed with lots of alerts when they're designed. and they continuously monitor themselves with anything that is out of the ordinary, and anything that goes outside the range or relational checks the chiller is already designed to send out an alarm or alert. So that's the first level of alert we collect. Some of the chillers have about 250 different types of alerts that are constantly being monitored by the chiller panels, and that data gets exposed. The big difference is that data gets continuously collected and stored. So not only you get those instantaneous alarms, you have the history of the alarms. We can go back and see. So if we think there's a problem, we can look back to see, is it a spot problem or has it been deteriorating over time? And that really helps to figure out an action. If it's a spot problem, is it because of the root cause? Is it because of the facility getting a poor power quality? And that's something we address with the facility, or if it is a continuous problem, we understand where it's coming from, so we can appropriately create a corrective action. So the chillers themselves provide quite a number of alerts. The second thing we leverage is the pattern recognition. Chillers do provide lots of data points, again, about 150 to 200 data points streaming in real time, depending on the type of chiller we are monitoring. And all those data points do have, again, range relational expectancies, and they also can be correlated to one another. So if one data point is starting to go outside the expected range, it might be because something else is going on, and having the full data set is going to be very valuable for us. So we do use the combination of data, pattern recognition, and progressively we are starting to use AI technology. AI is very good at detecting pattern recognition, and they are very good at catching things in very fast terms when it's not going, and they can correlate to past failures. So that technology that's becoming more the norm across any industry today is also starting to find its way in creating value in a chiller type environment, and we are fully leveraging that power of the technology to catch. So it's a combination of lots of data. In addition, our chiller experts, every one of our chiller experts have 20 to 40 years experience. This is what they've done most of their career, and we put that expertise to work on marrying the data. It's a combination of people, the subject matter expertise. The branches have very, very sophisticated folks who know how to action out a chiller. So a combination of all three is where we are creating value. We're not trusting anyone. All three have to come together to really create value for us.
Okay, great. And just to put a fine point on it, that's also the same process that we use for the optimization, correct? We're using the same data to see where there's improvement.
That is correct. Yeah, so the optimization is a science by itself. Understanding what's going on, a chiller is impacted by things that are outside chiller. Building loads are always changing, weather is changing. Chillers sometimes depend on cooling towers. There's a lot of water use, chemical use, and those has an impact of how the chiller is impacted. So we try to understand the operating environment of the chiller, not just the chiller itself, to really start to understand how do we help improve the performance. Sometimes, a lot of times when we talk to building operators, they're used to operating equipment like chiller for 20 years, 30 years. They have a certain way of operating it, and sometimes technology has far leapfrogged what they're used to. And again, understanding of what they're comfortable versus what the technology can do. Using data, we can find the gaps and help them understand. That's what the advisory services design is to be. We call it the phone a friend model. We are there to help, and sometimes we can translate the complex data into very simple actions. And that's part of how we want to create value for our customers.
Okay, great, thank you. We have one more question. It looks like the board is clear after this one, so we'll issue a last call for people to raise their hands or type in a new question. And the last question here is about the future. What significant changes do you see in chiller technology or design itself? And then how is the technology evolving, both with the chillers and the management, to be more green?
Sure, I think chillers, like most other building assets, are extremely important to keep progressing on energy performance and reliability. We are realizing, and I think the market is realizing, that this is no longer an option. We have had lots of customers who were not paying attention. All of a sudden, they get a mandate from their leadership with very stringent energy goals and very little time to achieve, and they turn to us for help, right? So we know this is becoming more and more important by the day. There's also a lot of regulation coming, regulation from a building level, regulation from refrigerant management level, And all of those we track very precisely, not just in one market. We track this globally, and we try to make sure we are building products and services that are progressively not just catching up, staying ahead of regulation, so that we are able to bring the best in class technology. We also, a recent few years have taught us that the supply chain problems are becoming more and more pronounced. So what would have been a reactive, if a chiller failed, you could go repair it and you could get a part 1 week away. That's no longer the case sometimes because of supply chain. That 1 week expectation could be 1 month today. So not letting the chiller fail is our #1 priority. So we are putting a lot of focus on what's happening in day-to-day market. Refrigerant costs are also going up, so making sure we are making sure the chillers are operating well. We're not letting leaks happen. All of those are very, very important. But overall, chiller is the most important device if you want to focus in terms of energy sustainability in your facility, because that is the largest energy using device. 10 years ago, it was lighting. Today, it would be the HVAC system. Start with the head end, optimize that, and as you go deeper and deeper into the building, it becomes more easy. So do not ignore those big boxes. Those big boxes do move the needle quite easily, quite quickly.
Excellent. Thank you so much. Well, it looks like that's all the questions that we had come in for today. So I think we can close out the session there. I want to say thank you to Arun and Caesar, both of you, for presenting for us today. And thank you to everybody who spent the time to join us. We hope you found the session useful and informative, and we'll look forward to seeing you on future webcasts. Thank you very much.
Thank you all.
Thank you all.